Okay, this is the second video for section 9.3. Here we're going to be finding trig functions given any angle. So in the last problem we found that, excuse me, the trig functions of an angle, but we weren't given the angle, we were given the point that its terminal side was on. What if instead we're given the angle? Okay, how do we find x and y and r if all we're told is the angle measure 135 degrees, for example? So let's see if we can evaluate secant of 135 degrees. And to do this, we'll start by drawing 135 degrees in standard position. You've had a little bit of practice at this now. Here's 90 degrees. I need to go another 45 to get to 135. So I'm going exactly halfway through the second quadrant. This is 135 degrees in standard position. There's my terminal side. Remember, for these problems, we also think about the reference angle. What would this reference angle be? The whole thing's 180. I've only gone 135 of the way, so 180 minus 135 gives me my reference angle of 45 degrees. Okay, remember, we always draw from the terminal side straight down to the x-axis to make our right triangle. And look what kind of right triangle I ended up with. This is one of my special right triangles, isn't it? It's a 45, 45, 90. What I want to know in order to evaluate secant is what are x and y here. I need to know what this point is, x comma y, in order to find x, y, and r, so I can use my general definition of trig function, which we saw right there, x, y, and r, to find, in this case, secant, but I could find any of the 6 trig functions using that, okay? So let's think about this special right triangle. Do you remember what the proportions are for 45, 45, 90? We'll draw them again. Oops. There's a 45, 45, 90 right triangle for you. Remember, we labeled the sides as x, x, and x rad 2. And we can pick any value for x we saw in class, and sine and cosine and the other trig functions will all still have the same value, right? So we can pick any value we want. I'm going to pick x equals, I'll let x equal 3, okay? Which would mean I'm pretending that this triangle has a dimension of 3, 3, and 3 root 2. Now the important thing is if this length is 3, and this length is 3, what coordinate is this? I've gone 3 to the left and 3 up. So 3 to the left means x is negative 3, 3 up means y is positive 3. I've already found, using my special right triangle, what r is in this case, although if I forgot, excuse me, I could always use the Pythagorean formula to find out. But here I already know, plugging in x equals 3, which is the number I picked, that the hypotenuse is 3 root 2. So r equals 3 root 2. Remember that secant of an angle is, let's see, secant's the reciprocal of cosine. Cosine is x over r. So secant is r over x. That's 3 root 2 over negative 3. My negative 3's cancel, and I get negative root 2. That's secant of 135. Now the one part that may feel a little arbitrary here is that we picked x equals 3. If you were to pick x equals 2 or x equals 7 or x equals, I don't know, 58, you would still end up getting the same value for secant of 135. So you can pick any value you want for x. We are going to want to pick a really convenient value for x. And think about the fact that we've defined sine as y over r and cosine as x over r. Sine and cosine are our 2 favorite trig functions. Actually, my favorite is cotangent. Okay, but most people really like sine and cosine. They're the 2 basic ones. They're the building blocks of all the other trig functions. And so let's look at these and think, how could we make these formulas a little easier? What would be a really convenient number for r that would make these formulas really nice and simple? You know what would make these numbers really nice and simple? If r equaled 1. Because if r equals 1, instead of saying sine theta equals y over r, if the radius happens to be 1, we can just write that sine theta equals y. That's pretty convenient. If the radius happens to equal 1, if the hypotenuse is 1, then cosine theta, instead of equaling x over r, it would just be x over 1, which is just x. So, these two formulas aren't always true. They're only true when r equals 1. But as you saw in the example above, we get to pick a value, we get to pick what size this triangle actually is. I could have picked 1 over root 2 to make the hypotenuse 1, in which case each of the side lengths would have been 1 over root 2. Let's try it that way. So I'm looking for sine of, or secant of 135. Okay, so here's 135. I'm looking for secant of 135, and I've got to pick what are my side lengths. I know that a 45, 45, 90 has dimensions x root 2, x, x. If I let x equal 1 over root 2, then the hypotenuse becomes 1 over root 2 times root 2. The hypotenuse becomes 1, and each of the side lengths become 1 over root 2. Now I'm looking for, so let's see, the coordinate here is negative 1 over root 2, comma positive 1 over root 2. I'm looking for secant of 135. Secant is the reciprocal of cosine, right? And when the hypotenuse is 1, as I just made it, cosine of theta is just going to be x, which means cosine of 135 equals the x value, negative 1 over root 2, which of course I'd need to rationalize if this were the actual problem. But this isn't the problem. The problem is to find secant of 135, which is the reciprocal of cosine. When I flip, I get negative root 2, which is the same answer I got above. So when we have our special right triangles with a hypotenuse of 1, for 45, 45, 90, as we just saw, each of the side lengths will be 1 over root 2, which when we rationalize, we get root 2 over 2 and root 2 over 2. So when the hypotenuse is 1 on a 45, 45, 90, each of the side lengths is root 2 over 2. When the hypotenuse is 1 on a 30, 60, 90, the shorter side is half that length, and the longer side is root 3 times the shorter side. These are worth having down in your notes, and over the course of the next few days, these are worth memorizing. 1, root 2 over 2, root 2 over 2 for a 45, 45, 90, and 1, 1/2, root 3 over 2 for a 30, 60, 90. When the hypotenuse is 1, as it is for these two special right triangles, our formulas simplify, as we saw. Sine of theta is just y. Cosine theta is just x. Their reciprocals are 1 over y and 1 over x. And tangent theta is still y over x, and cotangent is still x over y. These are for when the hypotenuse, or when r equals 1. So we can use this to find trig functions of any angle that happens to make one of these two special right triangles, as 135 degrees did in the last example. Let's try this angle, 11 pi over 6. Now, first we got to find 11 pi over 6 on the unit circle, or in standard position. Okay, so to do that, you can either convert 11 pi over 6 into degrees, by multiplying by 180 degrees over pi. Or you can do it by just counting up in fractions. Let's do it that way. That sounds fun. I like fractions. So here's pi, right? This is half of pi. Let's see, this is 1/3 of pi, 2/3 of pi, 3/3 of pi, which brings me to a full pi. So half of a third is 1/6 of pi. That's pi over 6. 2/6 of pi. 3/6. 4/6. This would be 5/6 or 5 pi over 6. 6 pi over 6. 7, 8, 9 pi over 6. 10, and finally 11 pi over 6. That's the angle I'm looking for. Guys, at this stage, if it's easier for you to convert 11 pi over 6 into degrees to find out where this is, that's fine. We'll find out that it's 330 degrees, which leaves us a reference angle here. Notice I drew from the terminal side straight to the x-axis to make my right triangle. The reference angle is 30 degrees, which means this is a 30, 60, 90. I get to pick whatever lengths I want as long as they fit the proportions of a 30, 60, 90 triangle. And I'm going to pick the ones where the hypotenuse is 1, which means the hypotenuse is 1, the shorter side is 1/2, and the longer side is √3 over 2. So for my triangle, that means this side here is 1/2, and this side here is √3 over 2. Remember, the goal of labeling these sides is to find what x and y are. I went √3 over 2 to the right, and I went down 1/2, so y is negative 1/2. Careful of those signs. That negative is important here. Remember, what I'm ultimately looking for is what is tangent of 11 pi over 6. Tangent is y over x. Negative 1/2 over √3 over 2. Remember, when I've got a fraction divided by another fraction, I have to multiply by the reciprocal of the bottom fraction. Negative 1/2 times 2 over √3. My 2's cancel. And I get negative 1 over √3, which, hooray! Now I get to rationalize. √3 over √3. So my final answer for tangent of 11 pi over 6 is negative √3 over 3. Yes. Let's see what we got next. 2 more examples, and then we'll be done. Let's find sine of negative 90. Sine of negative 90. So first of all, let's draw. This is something that would be impossible in a triangle, right? A negative angle measure. But in angles in standard position, it works fine. It just, instead of rotating up in the positive direction, I rotate in the negative direction. Here's negative 90 degrees. So this is the terminal side of that angle. Once again, this is another situation where it's impossible for me to make a triangle that actually makes sense with my angle. The good news is, if I use my general definition of trig functions, I know that sine of an angle is just the y value at the terminal side. And I get to pick whatever lengths I want that fit these special right triangles. And so, in the last example, we had that terminal side have a length of 1. And that's what we're going to pick here as well. The terminal side will have a length of 1, which means this has a length of 1. If that's the case, what is this point, x comma y? X is 0, and y is negative 1. See that this point here is the point 0, negative 1? So we're always going to be choosing that the radius, the hypotenuse, the length of the terminal side has a length of 1. Sine of theta is y. So sine of negative 90 degrees is the y value at that point. It's negative 1. The last problem for today is secant of negative 90 degrees. Secant is the reciprocal of sine, right? It's it's the reciprocal of cosine. 1 over x. In this case, for negative 90, the x value is 0, so secant would be 1 divided by 0. And you can't divide by 0. It's undefined. And so secant of negative 90 is undefined. All right, here are the 3 problems I want you to do at the end of your notes. These are from page 574. The first is like the first example we did. Let 815 be a point on the terminal side of an angle theta in standard position. Evaluate the 6 trig functions of theta. And number 15 says, find the 6 trig functions of theta if theta equals 7 pi over 2. So find sine of 7 pi over 2, cosine, tangent, cosecant, secant, and cotangent of 7 pi over 2. It's sort of like the example that we just did up here. And then lastly, find tangent of 240. All right, I'll see you in class.